eastern seaboard and southeast along the Atlantic coast, from Florida through the Carolinas and into the mid-Atlantic, the broad pattern shows a mid-level trough slowly propagating eastward, while a surface high pressure in the western Atlantic and a weak frontal boundary persist offshore. In Florida, moisture feed remains modest, with limited deep convection inland and fairly benign conditions overall. Expect relatively smooth flight operations across the Florida peninsula, though low-level moisture and shallow cumulus may produce isolated turbulence in the boundary layer. Moving north into the Carolinas and Virginia, a weak coastal front is draped parallel to the shore and drives modest enhancements in low-level convergence. This results in isolated showers and stratocumulus layers off the coast. From an aviation perspective, attention should focus on marine layer fog development, overnight in coastal and inland valleys, and moderate turbulence on departure, arrival. If the low-level flow strengthens, the geography of the Appalachians and coastal plain promotes low-level channeling. So even modest winds across the terrain can give boundary layer shear near the ridges. On the larger scale, the subtropical ridge is in retreat, and the downstream trough is beginning to build, signaling a transition toward a cooler, drier regime for the southeast by later in the week. Gulf Coast and Deep South. Over the Gulf region, the atmosphere remains relatively tranquil. A weak thermal gradient persists across the Gulf Coast as warm, moist air from the Gulf of Mexico flushes inland. Surface winds are light to moderate, and stability remains moderate to high. So convection is sparse. For airline operations, this means generally good conditions and minimal convective turbulence. However, in the warm, moist boundary layer, anticipate potential for sea breeze-driven cumulus over land and shallow thunderstorms inland this afternoon, especially in coastal Alabama and Mississippi, where daytime heating is greatest. These are locally generated and short-lived, so flight planning should account for localized convective buildups late day. The macro-scale forcing is weak. This is classic warm season transition behavior in the Gulf region, where moisture advection dominates but dynamic support is minimal. Central and Midwest. Moving into the central United States, a broad upper ridge dominates much of the plains and upper Midwest. That ridge suppresses large-scale ascent, so today's story here is one of subsidence, dry air aloft, and strong solar heating in the lower troposphere. Turbulent mixing will be strong, so expect enhanced boundary layer turbulence, especially over the southern plains into Texas and Oklahoma. This afternoon, pilots should anticipate moderate to strong mechanical turbulence in the lower levels where heating and mixing are strongest. At altitude, smooth conditions will prevail due to the lack of forcing, but the persistent ridge will delay frontal passages. On climate terms, this is aligning with the late autumn pattern wherein ridging over the central U.S. keeps moisture west of the Rockies and promotes drier and warmer than normal conditions for that time of year. Rockies and high plains. Over the Rocky Mountain region, a building upper ridge interacts with downslope flows and dry air advection. Surface winds from the west-northwest will accelerate down the lee slopes into the high plains, producing enhanced mechanical turbulence and gusty wind potential. For flights crossing the Rockies or descending into the plains east of the mountains, expect moderate to heavy turbulence in the lee of peaks as the mountain wave and strong boundary layer mixing take hold aloft. The stratification remains stable above the boundary layer, but locally unstable in lee troughs. So clear air turbulence might also occur in the afternoon, especially on northbound flights. The regional geography enhances this effect. Dry air, strong terrain, and a persistent ridge aloft make for the classic downslope turbulence regime. West Coast and Pacific Northwest. On the Pacific side, a cold front is digging into the Pacific Northwest and Northern California. Moisture overruns ahead of the front are producing widespread stratiform clouds and light showers along the coast and into the Cascades. For airline operations, low ceilings and marginal VFR conditions across mountain passes and coastal valleys in Oregon and Northern California. The front's dynamic forcing is modest but sufficient to generate lift and cloud decks. Turbulence should remain low, though if the front accelerates, the low-level wind shear could increase. The upper-level jet is rounding the base of the trough, which enhances lift just enough to maintain organized stratiform precipitation. Typical for this time of year in the region when Pacific systems begin to assert themselves. Further south into central and southern California, the ridge keeps things dry and stable, so operations there remain largely unaffected. Northeast and New England. In the Northeast, the trough is deepening slowly and a surface cold front is expected to settle across New England late in the day. Ahead of that front, southerly low-level flow is drawing rich marine moisture inland, giving rise to scattered showers and mist. For aviation, look out for potential ceiling reductions to an VFR or IF arcs, the coastal zones, and moderate turbulence in the low levels where the low-level jet is coupling with terrain influences. In New England's highlands, the climate transition toward winter is becoming more evident here. With the front expected, cooler air is poised to arrive. From a larger scale perspective, the polar jet is beginning its seasonal southward migration, and the trough ridge configuration is shifting toward a zonal Pacific flow, with implications for East Coast systems in the coming days. Summary and key takeaways. Today is a day of transition. Ridging dominates central and western areas, bringing dry and mixed conditions, while troughing and weak frontal systems begin to press eastward. From an aviation standpoint, turbulence risk is elevated in boundary layer mixing regions, central U.S., and downslope turbulence east of the Rockies. Low ceilings and mist are a concern along the Atlantic and Pacific coasts under shallow frontal/head of trough regimes. Overall convective risk remains low nationwide because deep forcing is limited. Many regions are simply in subsidence or weak ascent regimes. Mechanistically, we are in a post-warm season decline of the subtropical ridge, a gradual ingress of mid-latitude troughs, and an early signal of the higher latitude jet stream. Shifting south geography plays a vital role. Mountain leaf flows in the Rockies, sea breeze and Gulf moisture feeding in the southeast, and coastal marine influences along both seaboards. Each region reflects its local terrain and climatology while responding to the large-scale pattern. For today's flight operations and meteorological monitoring, focus on turbulence where heating or downslope flows dominate, ceiling reductions near coasts where marine and frontal interactions exist, and anticipate smoother long-haul conditions in the mid-upper troposphere, where ridging suppresses vertical motion. As we continue through the transition into the colder season, these dynamics will become increasingly pronounced. Safe flying and clear skies ahead.